Hello, I'm Shanmukha from Venkateshwara College of Engineering. Today, we'll be talking about Laplace transform application from subject mathematics and subject code 21MAT41. Let's look at the properties of Laplace transform. 1. Linearity. The Laplace transform is linear, which means that it satisfies the property of superposition. That is, the transform of a sum of a function is the sum of the separate function. Property number 2, shifting in time. The transform of a function that is shifted in time is equal to exponential times the transform of the original function. Property number 3, derivatives to multiplication by s. The transform of a derivative is equal to s times the transform of the original function. Property number 4, convolution to the product. The transform of a convolution of two functions is equal to the product of the transforms. Inverse Laplace transform. Its definition includes: the inverse Laplace transform is used to find the original function of a given Laplace transform. It can see as a Laplace transform in reverse. Its techniques include: there are several techniques to find the Laplace and its inverse, such as partial fraction, residue method, and the convolution integral. Its application: it is used to solve differential equations in time domain or to obtain time domain representation of the system. Let's take first application of this in CS. Feature extraction. Laplace transformation can be used in data mining to extract relevant features from large data sets. By transforming the data into frequency domain, it is possible to identify patterns and relationships that may not be apparently in the time domain. This can be particularly useful in image signal processing applications. Vibration analysis. Laplace transform is used in vibration analysis to convert differential equations describing the motion of a vibrating system into algebraic equation, making it easier to analyze the system's behavior. Noise reduction. In addition to feature extraction, Laplace transformation can also be used in noise reduction by filtering out high-frequency noise components. It's possible to improve accuracy and reliability on data mining algorithms. This can be particularly useful in applications where the data is subject to interference or other sources of noise. Let's take a practical example. This can be used in enhancing low megapixel photos and all. And this can also be used in digital to analog converters for the noise reduction. Robotics. This is one of the interesting fields. The transform can be used to analyze the design control system for robotics and industrial automation, such as position control and trajectory planning. It controls and gives the system power to analyze where actually an object is and to identify it and to like suppose let's take an example. We can write a code with Laplace transform so that the system can be able to locate and process the object available or put in front of it. MATLAB and Laplace application. MATLAB has commands that can be used to apply Laplace transform to linear systems for control system problems. The toolbox has additional commands for this purpose. Such commands that are useful for applications of Laplace transforms. Flight control. Laplace transforms can be used to design control systems for various aerospace applications, such as spacecraft altitude control, navigation and guidance, and autopilots. Electrical engineering. The Laplace transform is used in electrical engineering to analyze and design circuits. It allows engineers to determine the data transfer function of a circuit, which describes the relationship between input and output signals and processing of the data in between. This information is used to design filters, amplifiers, and other circuit components. Signal processing. In signal processing, the Laplace transform is used to analyze the continuous time signals and systems. It allows engineers to determine the frequency response of a system and design filters to remove unwanted frequencies from a signal. This is majorly seen in DAC, digital to analog converters. When we use digital to analog converters, there is a lot of noise or frequency absorbed. We use Laplace transformation to identify these disturbances and use a special software to remove it. Let's take a look at an application in signal processing. Laplace transform can be used to design filters such as low pass or high pass filters that can remove unwanted frequency components from the signals, as we discussed. System identification can identify characteristics of a system using measured input and output signals. In other words, we can find out the transfer functions of a system by analyzing its input and output behavior. Image processing. This is used in modern day applications such as image enhancer, shadow removal, brightness increase, contrast increase, and optimal photo quality. Transform in this transform can also be used to compress images or simulate the behavior of different systems such as image filtering, edge detection, and object recognition. It can also be used in photo modes such as portraits, portrait images, portrait videos, etc. Control system engineering. The Laplace transform is widely used in control system engineering to analyze the design linear time invariant LTI systems. It allows engineers to convert differential equations into algebraic equations, making it easier to analyze the behavior of the system under different conditions. Let's have a short summary or a conclusion session. The Laplace transform can be used in engineering application. A Laplace transform is a powerful tool that has many applications in various fields of engineering, from circuit analysis to aerospace systems, math and science. It has many uses in fields of physics, mathematics, and computer science. For instance, in solving partial differential equations in modeling systems, and it can also be used in collaboration and innovation. It's used in daily conversation, but no one actually notices it. It's important to realize that Laplace transform, like any other mathematical tool, is a result of collaboration and innovation over centuries that has enabled us to tackle many of the challenges we face today. Thank you. If you really feel the video is informative, a like and a subscribe will be supported.